Good morning and welcome to the Newseum on Pennsylvania Avenue in Washington, D.C. I'm Steve Cole from NASA's Office of Communications. We're here today to celebrate one of the longest-running newsmakers the United States has ever put into orbit, the Landsat Earth Observing Program. 40 years ago on this day in 1972, NASA, working with the Department of the Interior and the U.S. Geological Survey, launched the first Landsat satellite. Ever since, Landsat satellites have been beaming down detailed images of our planet's surface. Landsat has made news through scientific studies of global environmental change and through images of dramatic events like volcanic eruptions and wildfires. Landsat has also made a quieter sort of news, also in communities across the country and the world, by helping us manage our natural resources and our environment more wisely. We have a lot to show you today in the next 90 minutes. You're going to see a collection of the most important Landsat stories and images, and a collection of the most stunning images. You're going to hear about new technology scientists are using to turn the massive Landsat data archive into new knowledge. And you'll be the first to see how Landsat is helping 6 Americans better understand the landscape changes where they live. Our briefing today is divided into 2 parts. We just have so much to pack in. We'll have 2 opportunities for our audience here and those watching on NASA television to ask questions of our speakers. If you're watching online, you can ask your questions on Twitter by using this hashtag, AskNASA. And I wanted to give a special welcome to a group that's with us today. We have 24 of our social media followers here as part of a day-long NASA social for this Landsat anniversary. I think they're all seated up around here. Welcome. NASA and USGS both have a wide range of social media and you can use to join the conversation about Landsat and follow it into the future. Okay, so let's start the first part of the briefing. Our first 2 speakers will give you 2 different perspectives on the Landsat program. Our first speaker is Ann Castle, Assistant Secretary for Water and Science at the Department of the Interior. Our second speaker is Walid Abdelhadi, Chief Scientist at NASA headquarters. Following their talks, Ann and Walid will be joined for questions by 2 of our leading Landsat researchers seating next to them. First, Jeff Masick, NASA Landsat project scientist at Goddard Space Flight Center in Greenbelt, Maryland. And Tom Loveland, U.S. Geological Survey senior scientist at the Earth Resources Observation and Science Center in South Dakota. All right, well, we're ready for our first speaker. Ann?
Well, thanks, Steve, and good morning, everyone. Welcome to the Landsat 40th birthday party. We're very excited to be here to celebrate 40 successful years of imaging from space. You know, the Landsat program has given each and every one of us in every part of the world a thoroughly objective, continuous look at ourselves in the mirror since 1972. And it's given us very high-quality data, very carefully calibrated data. It's given us global coverage and global accessibility at no cost. So because of all that, Landsat has really become the gold standard of remote sensing from space. It's provided an invaluable, indelible record of the recent history of our planet. No other satellite program in our country or in any other nation in the world comes close to having the historical length and breadth and the continuity and the coverage of the Landsat archive. The Department of the Interior's policy of making this amazing archive available at no charge has allowed researchers everywhere, whether it's working in the private sector, working in universities, in corporate headquarters, or in developing countries, all of those researchers have this imagery available and can generate their own applications for Earth imagery. Those applications have served as catalysts for advances in commercial endeavors, in agriculture or forestry, in environmental restoration, in water management. They enable land managers to work more efficiently. They can define and tackle critical environmental issues. From the launch of the first Landsat in 1972 until today, the Department of the Interior has been the steward of our nation's imagery archive from the Landsat satellites. But if we go back even further, Interior has been a part of America's civilian space program even before Landsat. In the mid-1960s, there were USGS geologists and other scientists who recognized the value of classified land imagery, and they understood the potential of that imagery to help us get better geologic characterizations of the Earth, better management of agriculture and land resources. These scientists had even studied the pictures that were taken by the Mercury and Gemini astronauts with handheld cameras looking out the window at the land surface, and they realized that that kind of imagery too could help us better understand our planet. So in 1966, the USGS director, William Pecora, convinced the then Interior Secretary, Stuart Udall, to commit to Project EROS, the Earth Research and Observation Satellites. Secretary Udall made the announcement of the project by saying that the time is now right and urgent to apply space technology toward the solution of many pressing natural resource problems that are being compounded by population and industrial growth. Well, you don't need to update that quote at all in order to apply it to today's problems. It was Stuart Udall's announcement that became the catalyst for what eventually turned into the world's first civilian land imaging satellite, developed by NASA and launched on July 23, 1972, 40 years ago today. The first operational image that Landsat took in 1972 is shown here. It's Dallas, Texas. It was taken on July 25th, two days after the launch. And over the next 40 years, we've collected some of the most stunning imagery that you've ever seen. Imagery that has changed the way we think about our planet and has advanced our understanding of how it works. We're going to highlight for you this morning the top 10 stories in Earth's recent history that were objectively recorded by the Landsat satellites. And just like Landsat, we're not just going to talk about them, we're going to show them. And these pictures, I think, you'll agree with me, are worth about 1 million words. The first imagery that we'll look at is of Mount St. Helens. The 1980 Mount St. Helens eruption was one of the most significant natural disasters in the United States in the past 50 years. It laid waste to over 200 square miles of the landscape and deposited ash as far as 300 miles away. Landsat image captured the extent of the destruction, and the gray tones that you see here show the widespread lava flows and the ash deposits. Subsequent images over the years show the vegetation recovery across the site. The next imagery is of the city of Beijing. And the images that you'll see show the massive growth of that city that began in the 1970s. You know, we're seeing urban growth all over the globe, but Beijing's expansion has been anchored in geopolitical and cultural upheaval, and it's representative of the dramatic urbanization and industrialization of Asia during the Landsat era. Now we're going to take a look at some images over time of the Aral Sea. This sea in Central Asia began disappearing in the 1960s because of the diversion for agriculture of two of its source rivers. This series of images illustrates some unintended consequences from these water management decisions. The impacts of the Aral Sea decline have resulted in the destruction of the local ecology and fishing economy. And there have also been significant public health problems that have been caused by the airborne dust. Next, we'll see some Landsat images of deforestation in Amazonian basin in west central Brazil. And this imagery provided conclusive and impartial evidence of the increasing loss of tropical rainforests. As the impact of these images spread in the 1980s, they sparked concerns for tropical deforestation, and they actually stirred the global scientific community to increase the monitoring of forest loss from space. Next, we're going to see some amazing imagery from Kuwait. As Saddam Hussein's troops withdrew from Kuwait at the end of the first Gulf War, they set fire to over 650 oil wells, and they damaged many more. So here we have before, during, and after pictures from 1990 and 1991 that illustrate the largest release of oil into the environment in human history. By some estimates, the oil released was over 6 million barrels per day. The smoke plumes and the surface deposits were captured by Landsat for the 10 months of the time that the oil was burning. And these widely viewed images raised global awareness of the environmental consequences of war. Now we're going to take a look at some imagery from the international border between Mexico and Guatemala. Most borders aren't recognizable from space, but some appear in sharp contrast because of the difference in land use on either side. In 1988, the first publicized Landsat image of the Mexico-Guatemala border showed clear-cut forest in Mexico and untouched trees in Guatemala. Guatemala had been embroiled in civil war through the mid-1980s, and this area had simply been let alone. This image had a profound impact on the leaders of the two nations. It actually influenced the establishment of Guatemala's Maya Biosphere Reserve in 1990, and it also spurred the development of other conservation efforts in and throughout Central America. Now we're going to look at an iconic Landsat imagery of glacial retreat. The Columbia Glacier in Alaska is one of many receding glaciers around the world. And glacial retreat is one of the most direct and easily appreciated effects of climate change. The progress of decline in alpine glaciers is a factor in our estimates of global sea level rise. Next, we'll look at imagery from Yellowstone National Park and the fires that occurred there. We'll first see a 1988 image of Yellowstone, and it shows in red tones the extensive complex of fires and burn scars that occurred that year in the national park. The Yellowstone story dominated the news for the whole summer, and the recovery of the park that's shown in green tones in the subsequent visualizations has fascinated park visitors and ecologists ever since. Now we'll take a look at some agricultural imagery from Kansas, Garden City, Kansas, which is an agricultural region in western Kansas. We're going to see images from 1972, 1988, and 2011, and they show the transformation of farmland from rain-dependent rectangular fields to fields irrigated with groundwater. You can see how many of these fields became circular because they were being irrigated by center pivot systems. The mining of groundwater for agriculture has become a significant trend globally over the last half century, and this imagery helps us define it. Finally, we're going to look at Antarctica. In 2007, more than 1,100 Landsat images were assembled to create the first ever high-resolution, true color map of Antarctica. The Landsat image mosaic of Antarctica is a virtually cloud-free 3D view of Antarctica's frozen landscape, and it's produced by NASA working with the National Science Foundation, the USGS, and the British Antarctic Survey. So all of these images that we just saw are available to the public at no charge from the USGS Earth Resources Observation and Science Center near Sioux Falls, South Dakota. In addition to operating this center, USGS operates the Landsat 5 and Landsat 7 satellites, which are in orbit, and USGS has also developed the ground system for the Landsat 8 satellite, which will launch in February 2013. USGS also has very productive partnerships around the world with receiving stations that capture and share the global record of land change. Now, when Landsat was launched in 1972, the Earth's population was 3.9 billion people. Now we have 7 billion people on the planet, and we're projected by 2025 to have 8 billion. The natural resource management and development challenges that we faced in 1972 have not diminished at all. They've only gotten tougher, they've only increased. So we need tools like Landsat and the many applications that it spawned to keep up with those challenges, to manage those challenges. Even ancient philosophers like Socrates believed in the value of a distant perspective as a means to see the true nature of the world. Going back to 400 BC, Socrates said, "For man must rise above the earth to the top of the atmosphere and beyond, for only thus will he fully understand the world in which he lives." It's a wonderful motto, even though it comes from 2.5 millennia ago, for the Earth-observing satellite systems. In an era of growing populations that are encroaching more and more on our natural resources and more on each other, in a time of increasing competition for resources, we need this kind of observational tool to understand the impacts of our decisions and to increase our ability to provide for future generations. We can't afford not to get this objective perspective. Even in these times of declining public budgets, it's essential that we take the long view and that we continue to educate ourselves and our fellow citizens about the value of this objective data. It's essential that we ensure that short-term challenges and short-sighted opinions don't undermine our ability to fully understand the world in which we live. Thank you. And I'll turn it over to Walid Abdullati from NASA.
Well done. Thank you, Ann. I appreciate it. And I just want to point out, I was watching your faces as you looked up, and I think you all got sort of a sense of the wonder and beauty of what this capability brings. But in each of those images or image sequences you saw, there's a story. There's a story about the human relationship with the planet or with the region in that locality. And I often say, anyone who's heard me speak before has heard me say, I think of the Earth as a mosaic of stories. It's a lot of little stories telling one hugely important story, and that is the story of the Earth, the story of people on the Earth, and that interaction and how it comes. The beauty of Landsat is that it shows us familiar and recognizable aspects of the planet: cities, forests, coastlines, places we've been and places we might like to go someday. And it's important to recognize that the changes we see in these images, these evolutions over time, are really occurring against the broader backdrop of the changing Earth system, oftentimes in ways that are less immediately visible to the human eye. When the planet undergoes change, it affects us. Similarly, when we take action, we affect the planet. And there is a back and forth relationship there that's hugely important to our success as a species. And by observing in this way, observing from space, stepping back and taking the objective, comprehensive view, we're able to successfully execute that relationship. Oftentimes, it's important to recognize that the changes that we're seeing really are happening in a broader context, against a backdrop of a changing Earth. And this is why I love the quote Anne read from Socrates so much. It's really by stepping back and looking at the Earth, observing these changes in their context from space, can we really understand what's happening. And we do this in ways that are not really observable or visible to the human eye. We use different parts of the electromagnetic spectrum, wavelengths that our eyes can't see, to see things that our eyes can't see, but things that our bodies can sense, things that species can sense, things that humans react to, things that affect our everyday lives. And often the only way we can see these changes is by looking back at Earth from space in this way. We get to see the whole mosaic of stories and the intersections between them. I call this the power of perspective. Stepping back, watching change against a complex, beautiful, important backdrop. And with Landsat, the power of perspective is found not only in the spatial domain, not only in the spectral domain, looking at different wavelengths, but really in the dimension of time. By watching the evolution over time, we get a whole new perspective, in addition to spatial, on what changes are occurring, and ultimately, and perhaps more importantly, why, and how they fit into the broader context. And it's really only with these continued, consistent, objective observations over many decades in the case of Landsat, does this really become possible. Does it really become possible to watch the growth of cities and see how that growth differs around the world? Anne had shown Beijing. We have growth here in many cities throughout our own country, in this case Las Vegas, to see the disappearance of some of the world's largest glaciers, but not just watching them retreat. It was very illustrative what we saw with the Columbia Glacier, but these tools also help us understand why they're retreating. What you're seeing or will see is an image of the Jakobshavn ice stream, the fastest glacier in the world, draining the Greenland ice sheet. And by watching features move in time in Landsat imagery, we're able to watch the evolution of the velocity. So it's not just 3D, it's not even just 4D watching in time. It's the rate of change of velocity that helps us understand the contributions of these ice masses to sea level. To see the appearance of human-made structures like islands and dams. In this case, Poplar Island in the Chesapeake Bay. Not there, a human-built island that builds up over time from nothing to something. And to see how these human-made structures have long-lasting impacts on our land, rivers, and borders. What you're going to see is the Three Gorges Dam. And damming is actually a tremendous expression or manifestation of the human relationship with the planet. Working with, or tampering, depending on your view, with the natural processes to facilitate or improve or support life on Earth as we understand it. And you can see the effects of the dam through time, beginning in 1987 and then in 2006, what the retention of that water means. There's a story in that. Actually, there are several stories in that, as there are in all the other images that you had seen. Still, there are questions yet to be answered. We're getting a lot of answers from the Landsat data and some of the other observations, but there are many that remain to be answered. There are many parts of the world, of the Earth system, that still hold mysteries. There is much, much more to learn. And the key to learning really is going to depend, or does depend, on not just what we observe and how we do it, but what we do with that information, how we analyze it, how we put it together to tell that story. So today, I'm proud to introduce a new initiative that will open a whole new chapter of discovery using Landsat data. Today, NASA is making the NASA Earth Exchange, or NEX, project available to our research community for further research and development. We're looking at NASA and USGS's unique big data challenges and asking how can we glean the most important information from the vast wealth of high-resolution satellite data and turn that information into knowledge. We are making NEXT available through a proposal process, much like NASA science instruments or facilities, so scientists can use it for research. By using NASA's state-of-the-art supercomputing facility, researchers can explore large Earth science data sets in hours rather than months. The system is contains a large collection of global data sets from NASA and other agencies on surface water, weather records, topography, soils, land cover, global climate simulations, and more. And using NEXT, scientists can now fit Landsat tiles together like a giant jigsaw puzzle to create snapshots of global vegetation patterns containing over 500 billion pixels in less than 10 hours. I can't stress that enough. I mean, imagine anything you do being able to execute it in 1% of the time than what you usually do. The potential is tremendous. These images are 10 times the resolution of the traditional global vegetation imagery we've had in the past. And using online collaboration techniques, NEXT brings together multidisciplinary groups of scientists to focus on global change research topics ranging from global rates of forest change to the effects of climate change on the reliability of water resources. By looking into our past, observing the present, we can begin to paint an important picture about the future. There is value to knowing what tomorrow will bring. I don't think anyone will dispute that. And the key to understanding what lies ahead tomorrow and the key to facilitating the success of society in the faces of those changes that lie ahead rely on understanding the past, understanding the present, understanding those relationships and what that means for the future. We can position ourselves to succeed in the face of these changes, not just survive, but to thrive, to really make the most of the environment that lies ahead. And I like to say, and anyone who's heard me speak has heard me say, that the science we do at NASA, and I'll say the broader enterprise, the science we do from space is really science to inspire, it's science to serve, and it's science for our future. And I believe the Landsat program brings together all of these elements. By observing the beauty of the Earth in this way, it is inspirational. By observing the Earth and its interactions in this way, it's a tremendous service for society. By observing the Earth and its interactions in this way, we pave the way to a brighter future. And really, I don't think it's an overstatement to say the success of humanity hangs in the balance. And these are the kinds of tools, these are the kinds of investments that ensure that success. So thank you, and I'll turn it back to Steve.
Okay, thank you, Waleed, and thank you, Ann. All right, thank you both. And now we'll take some questions from the audience here, and we've already received some questions from Twitter, so I'll start with those, and then I guess there'll be a microphone going around. If you have a question here, please raise your hand. Let me start with one question from Twitter. Are there any plans to scrap Landsat and implement a newer satellite program?
I think the best response I'll give is that we are always examining our capabilities, our assets, and our needs, and we try to map those and the capabilities that are forthcoming to the needs of the nation. So, no, there are certainly not plans to scrap Landsat, but as a part of a continued evolution, we seek to achieve that capability in as innovative and creative ways as we can.
It's also probably worth noting that the technology of Landsat has in fact changed over 40 years. We're not launching the same satellites today that we did in 1972. The measurement objectives have maintained consistency, but the technology has changed.
And we are launching the next Landsat in 6.5 months, sometime around February 11th of next year. So we're certainly not on a pathway of scrapping this wonderful long-term system.
Okay, thank you. We have a question in the audience here, if you could identify.
Yes, Randy Shostak, reporter with EOS, the newspaper of the American Geophysical Union. While today's a celebration of Landsat, I'd appreciate if the panelists could comment on some of the concerns and challenges about the future of Landsat, including regarding contingencies if both Landsat 5, if it's still operational at all, and Landsat 7 fail prior to the launch of the Landsat data continuity mission. And Also in regard to a recent report by the National Research Council entitled Earth Science and Applications from Space that noted that the U.S. Earth observing system is, quote, beginning a rapid decline in capability.
Boy, there was a lot in there. Your last comment made me forget what the first question was. Can you repeat the first part of that question?
Sure. The
And
first
I'll
part
address the rapid.
regarded if you could comment on concerns and challenges about Landsat,
Okay,
including
sure.
regarding contingencies.
I mean, the concerns and challenges are really not much different for Landsat than it is for any mission. You know, these things cost money. And while I think those of us who work with the data, it's plainly obvious the value of that investment, and I think the return for the nation far exceeds by orders of magnitude the amount of the investment made. It remains a challenge to secure those investments and convey to the public, to sponsors, stakeholders, and so forth, how those need to rise in the face of many other stresses on the budget in general. So I think that can be said about any worthwhile undertaking. We're in a fiscally limited environment, and we're trying to make the best of those resources. With regard to the state of the Earth observing capability, I would point out we do continue to make progress, again within the constraints, the fiscal constraints and realities we have to deal with, to achieve the recommendations of the decadal survey, to achieve the scientific objectives that have been articulated, in part in new and creative ways, in part in the more traditional form, because we know that certain observations require certain techniques and capabilities. So it really is a broad, integrated approach that the biggest challenge we face is we're in an environment where we compete with many other stressors on the federal budget. So our answer to that is do the best and the most we can with what we've got, invest in small missions where it makes sense, airborne capabilities where it makes sense, bring together other observational capabilities that exist or will exist shortly where it makes sense, while moving forward to achieve the broader objectives of the earth science community and of society.
Steve, could I add to that, please? And what I'd like to do is just mention that from a Landsat data user's perspective, the critical issue we face is that of long-term data continuity. The concerns of the community is breaking the record that has existed continuously since July 23rd, July 25th of 1972. We have 2 satellites in orbit. You mentioned Landsat 5, that's 28 years old and clearly on the last months of its data collection mission. And Landsat 7 is in its 12th year, well past its design life. We're excited about the fact that the next Landsat is slated to be launched early next year. But after that, we still are on a tenuous path in which we don't know when the next mission takes place. And so the investments in science, the investments in operational activities are affected by the uncertainties that are the result of not transitioning Landsat into that operational program that gives all data users the assurance that the images they need will be available.
Also, Tad?
Yeah, I would just say that the general federal program of Earth observation satellites is in a transition from some research to operational. And that transition poses challenges regardless of whether we're talking about Landsat or weather satellites or whatever. And so we do have to come up with a framework for continuous operational launches, for continuous Earth observation capability, and the funding, as all of the speakers have said, is a challenge. But we also have advances in technology. We also have a proliferation of other types of satellites. And so one of the things we're doing right now is taking a hard look at what our options are for continuing the Landsat program specifically, but not necessarily in exactly the same way as before.
Can you elaborate on that any?
No.
Follow up at another time there, Randy. Actually, a follow-on question, different question from Twitter, but related to this conversation. How much money per year does it cost to keep Landsat operating in round numbers?
I actually don't know.
We actually derived that number recently, back of the envelope anyway. I think we concluded that it was about, over the life of the program, something on the order of 80 cents per person per year, more or less. And actually the cost of the satellites themselves has been pretty stable through time when you adjust for inflation over the last several missions, actually.
Okay, thank you. Another question from Twitter. We'll take that first. Are the colors in the images that we see actual color, or is some of it simulated to show certain things?
Good question. As you looked at red and green images, that would be a natural question. Landsat collects measures reflected energy from the Earth's surface across a broad range of portions of the electromagnetic spectrum. We see visible light, red, green, and blue light, as does Landsat, and we can take those measurements of red, green, and blue light and produce green-looking images much like we see. So that would be a natural color look. On the other hand, Landsat also measures invisible light in other portions of the spectrum, and so we can reassign colors to those to highlight particular features like the vegetation content of vegetation, the density, and other characteristics.
Okay, thank you. We have, I guess we have a question here in the audience. Please go ahead.
Thanks. Hi, Mike Bonham here with the NASA social event. You mentioned other satellite products, and one of the products that I use is MODIS data, provides near real-time change detection for forest pest events. I'm a forest entomologist with the U.S. Forest Service. One of the benefits of MODIS is we get data twice a day, and I'm wondering if the next Landsat mission, Landsat 8, will provide increased periodic data updates to allow for near real-time change detection. Do you have any comments on that?
Well, the repeat cycle for Landsat 8 is still going to be 16 days. However, assuming that Landsat 7 continues to survive for a few more years, we should continue with the 8-day coverage, effective 8-day coverage that we have before with Landsat 5 and Landsat 7 operating synchronously. I think there's also a lot of opportunity to bring in other international sensors into sort of a constellation framework. Europe is launching the Sentinel-2 missions in a couple of years, and so there's some possibilities to bring in additional data that could increase the effective temporal frequency of that type of observation through that mechanism.
Just one follow-up. So the product is a forest disturbance mapper through the U.S. Forest Service, and one of the reasons why it's so helpful is the data availability. The announcement that the data will be available in an expedited way to researchers. What is different about that to what's currently being made available? I mean, how is the...
Yeah, that's not as much about data availability as it is the tools to analyze the data. It's the use of the supercomputing facility, it's the development of software that you or other researchers could use to integrate that data into a meaningful way. That's different than, I think your earlier question was about the latency and getting the data quickly. This is independent of that.
Thanks.
Okay, we have one more question from Twitter at this part of the briefing. What are some of the most important long-term uses of Landsat data?
Well, I can point out one particular use that has been growing quite a bit lately. That's the use of thermal imagery for water management purposes. Techniques have been developed to use the thermal imagery to measure the consumptive use of irrigation water that's applied to the land. That has huge benefits for administration and management of water and water rights, particularly in the western United States. That's an application that I think we'll see expand exponentially over the coming years. Probably everybody has their favorite application, though.
Well, and I think in one sense that's a great question, because how do you pit the value of one tremendously valued piece of information against another? You know, my quick reaction is the most important thing it tells us is about ice, because that's what my research is. But if you think about coastal erosion, how ice contributes to sea level rise, the effects of urbanization, monitoring drought recovery, understanding disasters and disaster response, the soil moisture content derived from thermal and other measurements, and so forth. There's just such a long list of rich data products that it's really hard to pick one, but that's part of the charm of Landsat.
Yeah, we're often told that the Landsat community is an inch deep and miles wide, and I think that's consistent with what you've just said, Waleed. But if as we look at the investments made in this country, for example, the Department of Agriculture maps crop types across the nation every year in order to determine the particular areas of the various major commodities in the country. The U.S. Forest Service and the Department of Interior together monitor every large wildfire that occurs in this country continuously with Landsat. We have land use and land cover mapping programs that are ongoing across the country and around the world, for that matter, that are providing the evidence of land change that are needed both from the local levels up through states and national levels. So there really is an incredible diversity of applications that rely on the use of the data.
I'd also echo that the international applications are quite important. You know, the use of Landsat for tropical deforestation studies has really been seminal. We really didn't have a clue as to how rapidly tropical forests were disappearing until the early 90s, when those papers came out using Landsat time series. As we look at things like RED, the UNFCCC program to mitigate deforestation, Landsat will presumably play a very important role in implementing RED.
Okay, well, thank you to our panel. We've reached the midpoint of the briefing, and it's time for a bit of a breather. For the next few minutes, just sit back and enjoy the sheer beauty of our planet as seen through Landsat's eyes. Over the past several years, scientists at the Aero Center in South Dakota created a gallery of Earth is Art images. These have been wildly popular and have been displayed around the country. So, to celebrate Landsat's 40th anniversary, we invited the world to vote for their favorite images from the 120 images in the Earth is Art collection. Over 14,000 online ballots were cast, and today we are announcing the top 5. Roll the video of the top 5.
A series of Landsat satellites have surveyed the Earth's surface since 1972. In that time, Landsat data have become a vital reference worldwide, used for understanding scientific issues related to land use and natural resources. However, some Landsat images are simply striking to look at, presenting spectacular views of mountains and valleys, forests and farms. To celebrate the 40th anniversary of Landsat, the U.S. Geological Survey and NASA asked for your help in selecting the top 5 Earth is Art images. Number 5, Lake Eyre. Patches of shallow water in Australia's Lake Eyre resemble a skull. This ephemeral feature occurs in a flat, often parched landscape. Lake Eyre is Australia's largest lake when it's full. However, in the last 150 years, Lake Eyre has only been full 3 times. Number 4, Algerian Abstract. What looks like pale yellow streaks of paint slashing through a mosaic of mottled colors are ridges of wind-blown sand that make up a sea of sand extending from Algeria into Mauritania in northwestern Africa. In this area of ever-shifting sand, one of several in the Sahara, individual dunes often surpass 500 meters, nearly a third of a mile, in both width and height. The light blue areas in the image are salt crusts left behind from the evaporation of the valley's water. Number 3, Meandering Mississippi. Small blocky shapes of towns, fields, and pastures surround the graceful swirls and whirls of the Mississippi River. Numerous oxbow lakes and cutoffs run along the meandering river south of Memphis, Tennessee, on the border between Arkansas and Mississippi. The mighty Mississippi is the largest river system in North America. Number 2, Yukon Delta. Beginning in British Columbia and flowing through Yukon in Canada, the Yukon River crosses Alaska before emptying into the Bering Sea. Countless lakes, sloughs, and ponds are scattered throughout the scene of the Yukon Delta. The sinuous branching waterways resemble blood vessels reaching out to enclose an organ. It is one of the largest river deltas in the world and is protected as part of the Yukon Delta National Wildlife Refuge. Number 1, Van Gogh from Space. In the style of Van Gogh's painting Starry Night, massive congregations of greenish phytoplankton swirl in the dark water around Gotland, a Swedish island in the Baltic Sea. Phytoplankton are microscopic marine plants that form the first link in nearly all ocean food chains. Population explosions, or blooms of phytoplankton, like the one shown here, occur when deep currents bring nutrients up to sunlit surface waters, fueling the growth and reproduction of these tiny plants.
Okay, welcome back. We're here at the Newseum for the second part of our briefing on Landsat's 40th anniversary. Those images you just saw, the Earth is Art images, as well as the top 10 that Ann Castle mentioned, are online for download and viewing at this website, www.nasa.gov/Landsat. All right, for the next part of our briefing, we have something very special we did for the anniversary with the American public. In May, NASA and the USGS announced a contest that we called My American Landscape, a Space Chronicle of Change. It was a chance for Americans to ask Landsat scientists to take a look at landscape changes in their local area. We received 172 essays from people all over the country who were describing changes they had seen happening around them, and they wanted to know what Landsat saw or could reveal about those changes. So today we are presenting the 6 entries that our scientists investigated with data from the Landsat archive. For 3 of these entries, they created a quick look profile of the local changes. For the other 3, they dove deeper into the Landsat archive to see what the data could reveal. The 6 areas selected in Florida, Arizona, Nebraska, Louisiana, Colorado, and California represent the great diversity of different American landscapes. 4 of the scientists who worked on the American Landscape Project are here today to present the results. First, Jim Irons from Goddard Space Flight Center, who is project scientist on the next Landsat mission, the Landsat Data Continuity Mission, or Landsat 8. Roger Auk, a research geographer with the U.S. Geological Survey at the Aero Center in South Dakota. And Jeff Masick from NASA Goddard, who's been on the first panel, followed by Tom Loveland of the Aero Center in South Dakota. Jim Irons will give our first presentation. He'll present the 3 quick look profiles. These essays were sent in by Carol Halmberg, Planetarium Director at the Calusa Nature Center and Planetarium in Fort Myers, Florida, Mary Ann Vinton, Biology Professor at Creighton University in Omaha, Nebraska, and Justin Hirsch, a graphic designer from Steamboat Springs, Colorado. Jim?
Good morning. Our first example of an American landscape takes us to Lee County on Florida's Gulf Coast. This part of the country has changed dramatically over the last 40 years with a growing population, as described in the essay from Carol Homburg of Fort Myers, Florida. In 1970, the county's population was about 105,000 people, and a 1973 Landsat image of the region shows bright areas of development concentrated along the banks of the Caloosahatchee River in the cities of Cape Coral and Fort Myers. The surrounding areas of natural and cultivated vegetation appear red in this image. By 2010, nearly 620,000 people called Lee County home, with almost 24% of that population over 65. That's 10% higher than the national average. The result of this factor of 6 growth in the population is depicted in a 2011 Landsat image showing development expanded north to a perimeter of coastal mangroves and south along highways that link Lee County to Naples, Florida, another hotspot of urbanization. This development replaced the county's unique landscape of marshes, cypress forests, and upland pine flatwoods and prairies, including the loss of over 5,000 acres of farmland. Speaking of farming, we will move next to the Sandhills region of Nebraska, one of the largest areas of intact grasslands in the country, and an area that includes the largest grass-stabilized sand dunes in the world. Ms. Mary Ann Vinton of Omaha, Nebraska, brought this area to our attention. A 1972 Landsat image displayed on your left shows the sandhills south of the North Platte River, with semi-arid grasslands appearing green to gray and more well-watered vegetation close to the North Platte River and along other streams in the area appearing a bright red. Since the 1970s, the use of irrigation to grow crops in arid and semi-arid regions has expanded worldwide, and the Sandhills are no exception. The 2011 Landsat image on the right shows bright red irrigated fields of crops such as corn, soybeans, and alfalfa, now located in the middle of the grasslands. Most of the water applied to these fields is drawn from the underlying High Plains Aquifer, also known as the Ogallala Aquifer. Note the circular appearance of many of these fields as alluded to by Dr. Castle earlier in this press conference. This is due to the use of a popular and efficient method of applying water known as center pivot irrigation, whereby water is pumped up through a field-centered tube and out to a perforated horizontal tube that rotates like the minute hand of a clock, for those of us who grew up in the city. You can view such circular fields dominating the landscape as you fly over our Midwest and Great Plains, and indeed over many other agricultural areas across the globe. The next set of images moves us a little further west to northern Colorado, where Justin Hirsch from Steamboat Springs, Colorado, noticed severe forest disturbance. For example, a 2001 Landsat image shows a healthy, growing pine forest appearing dark green over an area of the Rocky Mountains just east of the Continental Divide and south of the Wyoming-Colorado border. A 2011 image stands in stark contrast, depicting wide areas of dead and damaged trees in extensive reddish-brown patches. This devastation is due to an outbreak of the mountain pine beetle in the western U.S., the largest and most widespread outbreak of the beetle in the greater than 100-year history of the U.S. Forest Service. This outbreak may be exacerbated by weather conditions in recent decades where drier conditions have weakened and stressed trees and where warmer winters may be helping the pine bark beetle survive the cold months. Steve, back to you to introduce a few more examples of our American landscape.
Okay, thank you, Jim. Well, our next American landscape takes us to Northern California, Trinity County. This essay was submitted by Roger Eckert of Burt Ranch, California, who is interested in the history of wildfires and logging in the forest lands surrounding his family's ranch. Our Roger Auk here will give the presentation. Roger?
Thanks, Steve. It's an interesting coincidence that Mr. Eckert and his family's association with Trinity County and the national forest there follows the same time span as Landsat's. So both he and the satellites have seen some of the same changes over time. In this feature, we are going to use Landsat's ability to look at changing land covers at multi-scales. We are doing this because the two main stories in Trinity County, wood harvest through logging and major wildfires, need to be observed at different scales. Trinity County is part of the greater Pacific Northwest region, and forestry land use has been a story there for a long time. I think we're going to start the logging video now. During this first several decades of the Eckert's family land ownership in the area, clear cutting of forest patches was a leading story of change. As seen in this 21-year span of Landsat images, clear cuts in the vicinity of Eckert's property show up as smaller, bright areas in this pan combination pinkish color where the trees have been cleared. These clear cuts then fade back to green over time as new trees grow up and eventually turn to closed canopy forest. In the next images we're going to see is an analysis of 4 dates between 1973 and 1994, an estimated 4.5% of the forest within 10 kilometers, which is 6 miles, of Eckert's property experienced land cover change. The spatial footprint of change by 1994 is quite noticeable as the different colored polygons represent the different number of times these parcels have changed land cover. Yellow for 1-time change, blue for 2-time change, and there's a few reds for 3-time change. But the trend for forest cutting had changed by the mid-1990s. In the preceding years, concerns about the region's forest age and composition and the overall ability of the Pacific Northwest forest ecosystem to provide all the goods and services that it had done so in the past had been raised, especially in regards to remaining old-growth forest. I'm sure many of you remember the spotted owl controversy. Advocates for a more holistic ecosystem services emphasis won out, and a federal policy changed with the adoption of the Northwest Forest Plan of 1994, and cutting on public land by clear cutting and public land was greatly reduced. Although wood harvesting by clear cutting was not prohibited by this new policy, such forest disturbance in the area became much less frequent. There was another change trend emerging, however, at about the same time, mostly independent of the forest cutting, and that was greater occurrences of wildfires in Northern California, many of them large in area extent. And I think we're going to start that video now. Although fire has always been a part of the forest ecosystem in the region, the rise of a greater number of fires have been linked to changes in climatic conditions, primarily earlier spring snowpack melt and potentially longer fire seasons. Mr. Eckert mentions 3 major fires in his essay, and they, along with others, show up in his collection of Landsat images over the last 16 years. The first very large fire that you saw was the Big Bar Complex fire that burned over 150,000 acres in 1999 and show up very distinctly the next year as the severely burned areas were purplish red in the Landsat imagery. The next fire was called the Bar Complex in 2006, and then the Iron and Alps Complex in 2008. Old burned areas still show up as pinkish red as the vegetation growth, especially new trees, is still limited. To conclude, forest disturbance is still a major changer of land cover in Northern California, although the nature of disturbance has changed over time. Wildfire now appears to be the leading type of change and will probably remain so in the near-term future. Back to you, Steve.
Okay, thank you, Roger. Our next American landscape is in Maricopa County, Arizona. This essay was submitted by Michelle Fuller of Gilbert, Arizona, a 4th grade teacher who was eager to teach her students about the changing patterns of urban and agricultural land use in the Phoenix area. This presentation will be given by Jeff Masick. Jeff?
Thanks, Steve. So the migration of Americans to the Sun Belt has been one of the big demographic trends in post-World War II America. And this trend is really well epitomized by the growth of Maricopa County and Phoenix City during the Landsat era. And this evolution also illustrates in a very concrete way the ways in which water and water scarcity have influenced development in the American West. In fact, water was really central to the founding of the city of Phoenix to begin with in the late 19th century. After the Civil War, developers discovered that they could reuse ancient canals dug by Native Americans to bring water from the mountains to the Salt River Valley. In fact, it was the fact that these canals represented a rebirth of technology from an abandoned civilization that gave rise to the name Phoenix in the first place. With abundant provision of water, agriculture in the valley flourished. If we look at the first 1972 image of the Maricopa County area, what we see is that Phoenix has already begun shifting away from a purely agricultural economy, though, to one based on manufacturing and residential housing. This trend actually began in the World War II era when airmen who trained in Arizona because of the clear skies came back after the war and moved to Phoenix. This ultimately spurred both the aerospace and the electronics industries in the area. Now, in this first Landsat image, again, this is one of these false color images like Jim showed earlier, with the healthy vegetation being bright red. And you can see the sort of reddish-gray smudge in the center is what at that time was a fairly compact city of Phoenix. In fact, there's still quite a bit of agriculture in the eastern Maricopa County area, and Chandler, Arizona, where Michelle Fuller lives, was still an outlying community east of Phoenix South Mountain. As we start the animation, we can see the urban development of Phoenix over the next 40 years. At first, your eye is sort of drawn to the flickering of the agricultural fields. That's simply year-to-year changes in cropping. But the real story here is the rapid growth of the urban area and the decline in total farmland through time. Over the course of the animation, the population of Maricopa County quadruples from 960,000 in 1970 to over 3.8 million in 2010. And much of this, although not all of the development, came at the expense of farmland. The Census of Agriculture indicates that about 1,000 square kilometers of farmland was lost between 1974 and 2007. As we look again at the animation, it's useful to think more about water. While the early 20th century Phoenix had an abundance of water, rising populations began to strain that resource by the middle of the century. The 1980 image shows a strange white scar appearing across the northern part of the image area, and this is the Central Arizona Project waterway, which brought water from the Colorado River eastward to the Phoenix area. Today, Phoenix gets about 44% of its water from the Colorado River, with most of the rest coming from the local Salt River. What's interesting is that despite explosive population growth, Phoenix as a whole uses about the same amount of water as it did 10 years ago, thanks to aggressive conservation. However, climate change and drought may affect the flow of the Colorado River in the future, leading to greater challenges to come. Our final view of Maricopa County growth comes from a processed version of the Landsat time series, where the spectral data have been converted to maps of impervious surfaces. And these surfaces are basically concrete, asphalt, and roofing materials. And they affect both the flow and the quality of water that comes into the waterways in Maricopa County. And this particular sequence of images also provides a very graphic view of how the built area in Maricopa has expanded from 1972 to 2011. It's interesting to note that in these image time series, the growth since 2009 seems to have leveled off considerably, probably due to the Great Recession and the housing bust that affected the Sun Belt in particular. It's going to be interesting to see if, as that recession eases, development again picks up the pace that we saw before. Now, finally, I'd like to note that for those of us who work on the Landsat program, these images have a special resonance because the next Landsat imager, the Landsat Data Continuity Mission, is currently being assembled by Orbital Sciences Corporation in Gilbert, Arizona, which is just a stone's throw away from where Michelle Fuller lives. So it's actually kind of interesting that in the last few images of that sequence, the previous Landsat system was actually imaging its successor. So that gives us a good feeling. Back to you, Steve.
Okay, thank you, Jeff. And our final American landscape today is Vermilion Parish in Louisiana. This essay came to us from Brent Yantis and Whitney Broussard of Lafayette, Louisiana. Brent is a landscape architect at the University of Louisiana at Lafayette, and Whitney is a researcher at the university. They wanted to look at changes to the wetlands along the coast of southwestern Louisiana. Our presentation today will be given by Tom Loveland. Tom?
Thank you, Steve. Our final landscape change story illustrates the complexity and the constancy of land and water change. In southwestern Louisiana, the centuries of lower Mississippi River wanderings, the periodic hurricanes that flow through the area, and past and present human enterprises have combined to have a pronounced effect on this unique region. When we take a look at the Louisiana Shinnery Plain, and especially the Pecan Island area of the Vermilion Parish, we'll see that the area consists of a series of marshes, open water bodies, and ridges known as shinneries, that are formed from shell sediments and are shaped by the ancient activities of the Gulf of Mexico. These elevated ridges, a few meters tall at their highest part, are the preferred sites for the region's residents, due in part because of the protection they provide from flooding. The original residents, such as Pecan Island's residents, made their living off the surrounding marshes by farming, fishing, and trapping, although more recently they're now making their livelihoods in areas such as the oil and gas industry. The 1973 Landsat image shows considerable amounts of open water, those smooth colors in blues and turquoises that are scattered throughout the images. The marshes are represented by the tones of reds and other dark shades that form mosaics, particularly south of the line that forms the ridge and the highway around Pecan Island. The sequence of 6 Landsat images that are being shown center on the community of Pecan Island that's located on one of these high ridges, and it is right in the middle of the salty water to the south from the Gulf of Mexico and the fresh water in White Lake. This is an extremely ecologically rich region. As you look at these images that span 1973 to the year 2001, you'll see an increase in open water, and you'll see a loss of salt marshes. You'll also see the loss of agricultural lands, some of the uplands to the south and particular to the east. Perhaps most pronounced in the changes that you see are in the marshes, which are caused in part by the impacts of distant engineering efforts to control the lower Mississippi River, hundreds of miles away, and also the impacts of the construction of access canals and shipping canals throughout the marshes. The canals and the river modifications of the Mississippi have combined to affect the flow and the amount of open water found throughout the area. As we look at the images, we'll also see that lands that were dry in 1973 become flooded in 1980. Ultimately, the marshes are being affected by encroachment from salt water, rising sea levels, and are essentially less resilient than they were before. Hurricanes such as Danny in 1985 and Rita in 2005 have inundated the marshes further, as well as the agricultural lands. The town of Pecan Island is somewhat protected because of the higher ridges of the Shinnery, but in effect, the constant dynamics in this region have really changed the overall ecosystem of the area. The changes that have been going on here have been going on for many, many years. Certainly Landsat's first image in 1972 and the subsequent observations that have been gathered have continued to document the complexity and the constancy of this change. The southern Louisiana community, including Mr. Brett Yantis and Dr. Whitney Broussard, are rallying behind the people of the Shinnery Plain and are researching sustainability strategies that they hope will help communities cope in this dynamic environment. They hope for a future that will maintain the cultural and the ecological resiliency of this uniquely American landscape. Back to you, Steve.
Okay, thank you, Tom. Well, clearly, as you've seen here, Landsat has shown us a lot about our own place on the planet over the last 40 years. But what of the future? Several people have mentioned that there is a new mission on the drawing board, and actually beyond the drawing board, almost ready to launch. And we're going to have an overview of that as our last presentation. To give that presentation is Jim Irons, who is the project scientist for the Landsat Data Continuity Mission. After Jim's remarks, we will open it up to questions again to everyone here and to those watching online. So, over to you, Jim.
Thank you, Steve. I suspect there's some sore necks in our audience here at the Newseum because I've watched you out here looking up with fascination at those awesome examples of landscape change shown on the screen above us. Those landscapes and their change were reported by Americans on the ground and observed from the Landsat satellites in space. Such changes are ongoing around the world as we speak, and I'm pleased to report that we plan to launch the 8th satellite in the Landsat series in early 2013 with a launch readiness date of February 11th. It will continue Landsat's monitoring of global forests, agriculture, water use, urban development, glaciers, and all other surface features around the world at a scale where the human impact can be differentiated from natural variation. This 8th satellite is currently called the Landsat Data Continuity Mission, or LDCM, and as with the rest of the program, it is managed by a NASA U.S. Geological Survey partnership. NASA has the lead for building the satellite and launching it aboard a United Launch Alliance Atlas V rocket. LDCM consists of the spacecraft built by Orbital Sciences Corporation and its 2-instrument payload. One of those instruments, the Operational Land Imager, or OLI, was built and delivered by Ball Aerospace and Technology Corporation and will collect image data for 9 spectral bands across the visible, near-infrared, and shortwave infrared portions of the spectrum. It's shown here at Ball Aerospace with Ball technicians wrapping it up in its cover that will be used to protect it in space. The second instrument, the Thermal Infrared Sensor, or TIRS, was built and delivered by NASA's Goddard Space Flight Center, where Jeff and I work just up the road in Greenbelt, Maryland, and it will collect image data for 2 thermal infrared spectral bands. Here it's being showed in a test where the Earth Shield is deployed. Both sensors include technology advancements that will improve performance relative to earlier Landsat instruments, while still collecting data that is consistent and comparable to all of the data from those earlier missions. The satellite, which will be shown here in a moment, with its 2 instruments mounted on the optical deck, is currently in the integration and test phase of development at the Orbital facility in Gilbert, Arizona. In the fall, it will be shipped from Arizona to the launch site at Vandenberg Air Force Base in California. The U.S. Geological Survey leads the development of the LDCM ground system and will assume responsibility for satellite operations after launch using a mission operations system developed by Hammers Incorporated. The ground system also includes a data handling system at the Aero Center in Sioux Falls, South Dakota. That's where the data will be captured, archived, and distributed as part of the USGS archive of over 3 million images from the Landsat satellites, an archive that goes all the way back to 1972 when we took the first Landsat image. Consistent with current policy, the U.S. will provide public access and open access to this archive and distribute image data from Landsat 8 for free over the internet. Did I say Landsat 8? Well, our USGS partners assure those of us at NASA that they intend to rename the LDCM satellite Landsat 8 after we launch it in February of 2013, so it will be consistently named with the rest of the satellites in this series. 40 years ago, visionaries realized that observing our Earth from unmanned orbiting satellites would be an invaluable component of a U.S. space program. One of the first realizations of that vision was the launch of Landsat 1 on this day, July 23, 1972. We have since kept at least 1 Landsat satellite in operation at all times for those intervening 40 years, while still advancing technology and improving our capability to analyze, interpret, and distribute Landsat data, as mentioned when Dr. Abdulati talked about the NEXT system. The result is an unparalleled record that allows us to monitor and better understand dramatic changes to our global forests, cities, farms, water resources, coastal areas, ice caps, glaciers, and all other land resources. We intend to preserve that record and add to it with the launch and operation of LDCM, Landsat 8, and as with all of our nation's space exploration, we do so for the benefit of all mankind. Thank you.
Okay, thank you, Jim. All right, we have several minutes here for questions from the audience, and we've already received several from online via Twitter. Let me ask that first while we see if anybody here has questions. The first question, has NASA looked into making Landsat imagery more mainstream by merging it with Google Maps?
Who wants to take that?
Let me address that. Landsat is heavily used by Google. If you look at Google Earth or any other aspect of it, you'll frequently see Landsat images, so it's already being used. Others are also trying to make Landsat more mainstream, and in fact, a product called Landsat Look is going to be made available starting today with a new interface that will make it much easier for people to access imagery for their everyday use.
Okay, thank you. One more question on Twitter before we go to the audience. What is the most viewed or most recognizable or most downloaded Landsat image? If anyone has that data.
I assume it has to be the image of Sioux Falls, South Dakota.
I think it might be Washington, D.C. would be my guess, but I don't know.
I don't know. That's a good.
Okay, we'll have to research that.
Stump
That's
the panel.
a piece of data we haven't acquired for Landsat yet. Okay, we have a question here in the audience. Please go ahead.
Yes, hi. My name is Brandon Brooks, and I'm here from NASA Social. And my question is, how fast is the Landsat satellite orbiting the Earth, and how much control do you have over, what you can take an image of? Like, can you go back and forward? Or?
Yeah. So every orbit, it's in a polar orbit, goes over the north and south poles. Every orbit takes about 90 minutes. Each satellite has been maintained in an orbit to take it over the same sequence of ground tracks. And those sequence of ground tracks are repeated every 16 days, so we get global coverage once every 16 days. We do not manipulate the satellite, and fly it all over space. Its orbit is adjusted to maintain it along that sequence of ground tracks.
Okay, thank you. Another question here in the audience.
Hi, I'm Sharif from the NASA Social. I was curious if the technology used for Landsat is a technology either used now or planned to use as we look at other like moons and planets in the solar system.
Want it, Jeff? You want that one?
Well, actually, the imaging technology is very much like what's used for passive optical and thermal observations of other planets. Some of the bands, of course, are tuned to features on the Earth. The Earth is the only planet that has life. And so, for example, the near-infrared channels are really tuned to look at vegetation patterns on the Earth. So the particular bands that we use are tuned to Earth and ecosystems, but the technology in general of using scanners and push broom solid-state sensors is used on other missions, yes.
Okay, we have another question here in the audience. Thank you.
Hi, I'm Liv Hood. I'm with the NASA Social Media event as well as Telescience Museum. We actually had a temporary gallery of Landsat images this past spring, and the kids around 10 and 12 really, really loved it. So I have to ask a question that I overheard there, which is, what is the coolest thing you personally, your favorite image that you've ever taken or seen with Landsat?
That's a tough one, because I've been looking at Landsat imagery on daily basis for about the last 10 years. I guess when I get surprised, if I'm looking at an area, typically smaller areas that haven't changed, and all of a sudden I go 5 years later and all of a sudden, boom, all the trees got cut down, or some big large mine opened up, or some event happened that makes a sleepy area, or at least sleepy from the Landsat, all of a sudden be very dynamic. So it's always a wow factor, I guess. You never know what the next image is going to be.
Okay, another question here.
Yeah, Leah Shanley here for NASA Social. What inspired all of you to become remote sensing scientists?
As the oldest one up here, it appears, I took my first class, university course in remote sensing, the study of distant objects without direct contact, in 1972, right before Landsat was launched. Never saw an image, but learned a lot about the potential for understanding the Earth from a distance, and it fascinated me. Well, I just also happened to grow up in the state of South Dakota, very close to the Aero Center. And so I got involved by walking in the doors shortly after it opened and said, could you give me a job? And at that time, there weren't a lot of people that understood what remote sensing was, and so I got hired. Pretty easy, huh?
I guess in my case, I started out as a solid Earth geophysicist, and I enjoyed that, but I actually wanted something a bit more practical, something a bit more applied. And so looking at global vegetation patterns seemed to be a way to take my science and actually make it matter to people more directly.
I'm also a historian besides a geographer, and the German philosopher Immanuel Kant once said, history needs space to happen on, and space has a history to it. So it's a yin and yang. And so what else better to look at constantly a temporal pattern of the Earth?
I'm a child of the 60s and grew up with the environmental movement. I was very fortunate to, when a college student, to get a summer job at NASA Lewis Research Center, now Glenn Research Center near my home in Cleveland, Ohio, and was assigned to a group doing remote sensing of water quality in the Great Lakes. My job was to jump into the Lake Erie and get some water samples, be a typical kind of student job, and my career started there.
Okay, thank you. We have another question here in the audience.
Hi, my name's Amy Lanky. I'm also with the NASA Social event. Do you guys ever find yourself staring down at images of our weather patterns, of the aurora, of even like our planes and stuff like that, that you would just, I know it's in low Earth orbit, so I didn't know how clear you can see some of that kind of things.
I'm sorry, because of the background, I couldn't hear what was the question? Again, please.
I know it's in low Earth orbit, so I don't know what all you can see covering. Do you see a lot of the weather patterns? Do you see the aurora, even our planes down there, anything like that?
I mean, in general, we don't see we try to avoid the atmosphere and the clouds as much as possible. We have actually had some scientists at Goddard who have focused their research on cloud patterns from Landsat. There's a particular aspect of Landsat because it can see small clouds that some of the global sensors can't see. You can actually do scaling studies of the size of clouds with the system. But that's about the only atmospheric application of Landsat. We're really focused on the land dynamics and resources.
Yeah, I think one of the Earth of Art images is near an island, but it was patterns of clouds and not being a meteorologist, I forget the...
Vortices.
What are they called?
Vortices.
Vortices of clouds coming downwind from some islands, and it's in the Earth's Art collection, and it's not only interesting, it's beautiful. So.
Okay, thank you. One more question from Twitter. This is a longer one for Twitter. Knowing the changes and impacts we have made to our world by seeing the Landsat imagery, are there plans in place to adjust and correct the effects we have had on our home planet to prevent harsh effects or the worsening of effects already in place?
Let's hope so. Landsat is an objective source. You know, it's the equivalent of the Earth's free press. It provides the evidence of what's happening on the Earth. It helps us understand the consequences of those change, and it has information that then needs to be used by policymakers and decision makers to come up with management strategies or practices that mitigate those effects. That's really why we're all in this, is to try to provide that indisputable evidence that can be used by people that are trying to make wise decisions to improve our resources.
Okay, thank you. Well, that's our last question. We've run out of time. I wanted to thank all of our panelists. And as a reminder, you can see all these images, a lot of the stories having to do with Landsat are online at www.nasa.gov/Landsat. And you can continue to follow the conversation about Landsat on Twitter with the hashtag Landsat. Anniversaries are a good time to step back and reflect on what we've accomplished. And I think you've seen here what the United States has achieved through the Landsat program. Bottom line is we're all much more in touch with our planet thanks to Landsat. Happy 40th. Thank you all.